You looked at parent graphs, and now we're going to do transformation, move the graph around, change it by stretching it and making it wider. So just to let you know, if you don't have any color pen or pencils, you may want to use different symbols as you're going through and doing the transformations. I will be doing the graphs as much as I can in color so you can keep things straight. And here we go. Here's the definition for the transformation. So first we're going to start with the parent function, which I'll graph in a little bit. And we're only looking at the quadratic equation today. But of course, all functions will work in the same exact manner. Okay, how do we know it's quadratic? We know because of the power 2 right here. And we'll go over where the points and the shape come from. But right now, I want to show you the transformation formula. So this is the transformation formula. Okay, so that is the following. So this is called the vertex form. And that is because it really tells us where the vertex is, but we'll talk about that more later. Right now, we're just gonna talk about how this function in this form moves around and how to identify it. So this A value represents a vertical shift. Not a vertical shift, it's actually a vertical stretch. So when I'm talking vertical stretch, it can make the graph more narrow, like skinny, or it can also make the graph wide. So something like that. It depends on what that A value is out in the front, which we'll look at later in one of the examples. If you have a number and that number is h, it's attached to the x value, which means you're going to have a horizontal, and I wrote the arrows so you knew what horizontal is. This is a horizontal shift. And depending on the sign, that tells us which direction to move. And I'll be showing that to you later in some examples. And then finally, we have the vertical shift. And the vertical shift moves up and down. And that again is dependent on the sign. So I should put over here left and right. And that is how the transformation formula works. So take a minute and really understand the notation as we're going through those examples. Good morning. This lesson is on transformation of parent graphs. We're starting with quadratics. So make sure you get out a sheet of paper and we're going to get started. So you need to label these nodes parent graphs and transformation. And we're going to be looking at primarily the quadratic equation. So I'll call it a function just to stay consistent. And remember that parent graph, so the parent graph is f of x is equal to x squared. So if you called it the squared graph, that would be fine as well. So now that we understand where the parent graph is coming from, and I will go over and review it again, but you watched a video on it before, now we're going to start shifting this around, and this was a review for Math 2. So let's first graph the parent function so we know where it is coming from. So if you recall the numbers that we used to make a nice pretty graph were these input values, or these values from the domain. And when I performed the operation, which over here, I'll try to be more precise here, this is the y value, but it's the functional value. So it's the functional value at -2. And I'm gonna write it longhand, because remember, this is equal to x times x. So we don't accidentally make a sign error. I know some of you can do it in your head. We've talked about that in class. I want to make sure everyone can do it. So this should feel pretty good to you. At this point, you should have these parent values memorized. Like, what are the x values I need to substitute into the function? And in general, what does my graph look like? So in general, your graph looks like this. It's a U. And it has a absolute minimum. And remember that minimum value is described as y equals whatever the y value is. So in this case, it would be b. Okay, so I'm going to come over here and graph the parent function, but I'm not going to connect the points. And I want to stay consistent with my colors so you know exactly what I'm doing. And you too will get very quick at knowing where this graph is. So remember, there's a connected line here. And when I say line, I really mean curve. And there's arrows, and it's infinite. All right, but now we're going to start the transformation. So I'm going to go ahead and show you what that graph is going to be. So we're going to start with, so that was the parent graph. We're going to start with number 1, because all of these are going to stem from the parent function f of x equals x squared. Okay, and this really is number 1 right here, so put your parent points on your graph. And we're going to start by graphing this guy right here. So what this says is take the parent graph, and because this value on the end here, which really represents the shift up and down, so this is the vertical shift because you'll hear that vocabulary. Since the number is negative, you're going to move all the parent points down 8. So parent points are going to go down 8. So here are my parent points. That's the x squared represented by the black. Here we go. And then I just want to show you something really quick. Since we don't have a stretch, which we will be doing, you can kind of use the point where the absolute minimum is located, kind of like that guide, because nothing else changes. So this is a rigid, meaning the shape does not change. So everything is in the same placement. It's just all moved down 8. So here is your graph. And yes, you need to connect this the graph that you are being asked to graph, not the parent graph. See how I didn't do that? But you definitely need to have those arrows in there, okay? On any kind of test or quiz, I would mark you down on that. So that is our first graph. So what did I do? I used the parent graph and created a table, and then I moved everything down 8. Hopefully this is, again, review for you. Okay, here's number 2. Okay, I'm going to put my parent graph on here without connecting them, just kind of for perspective as to what I'm doing. And then this time what you need to notice in this particular equation is that since this 2 right here is attached to the x value, you're going to move horizontally. This is a horizontal shift. So you're moving from left to right. Now the question is, based on this function or equation, which way do you move? And you move in the following way. So how do you get a minus sign when you're doing multiplication? It would be a negative times a positive. That's where the negative is coming from. This is how all the graphs you're going to work. And so you're moving right. You're moving right 2. So all these values are going to move right 2. I know it looks strange because when you look at the original equation, it looks like you go left, but you don't. There's some hidden signs in here, so you have to look out for those. So I'm going right 2. And then I'm going to connect the points for the graph that I'm being asked to graph. I'm going to stick arrows. You're going to make it nice and neat. And there you go. So remember, when you have a negative sign here, you go to the right. All right, next graph. I'm just going to get rid of the title because I keep erasing it. So just to make sure that you're not confused on that, I'm now going to graph this way so you can see just a very quick example when to recognize when to go to the left. There's my parent graph, okay. This 2 is attached to the x, so I know I'm moving horizontally. So we're going from left to right or right to left, depending on which direction. All right, so I'm going to rewrite the function here. And how do I get with signs? When I multiply them, I get a plus sign. Well, that's a negative, and a negative become a positive. And so now you can see we're moving left 2. So I'm going to take all these points and move them left 2. And so moving across, I'm moving across the x's, because remember, this value 2 is attached to the x's. You just have to make sure you're keeping track of those signs. So the next type, we're going to start putting some of this stuff together. So I think this is number 4. So we're going to do, let's do x plus 2, which is what we just did. So you can see that connection. And then I did minus 8. So now we're combining the 2 examples, and we're going to do 2 steps in one quadratic equation, so that U shape. So just coming over here and doing the parent graph, and if you ask me, oh, well, do I have to do that? Yeah, I need to see some evidence of you understanding how these points shift, okay? And not just putting in a graphing calculator and then just copying the points. So I need to see that. All right, so there's 2 things going on in this example. One is we have a shift going left, left, right, or right to left. And then I have the y values moving down. And it doesn't matter which order you do them. I'm gonna do them, I'm gonna do the transformations in 2 steps. So I'll do the pink first, and then I'll do the blue. But it doesn't matter which order you go in. So I'm gonna rewrite this equation. So what 2 signs that when you multiply them, you get a positive, besides a positive and a positive. So this is squared. And it's based on the formula that I showed you at the beginning of this video. So there was a minus sign in the beginning of this video, and so you can't just say plus plus, because that isn't how the formula works. So we're shifting the whole graph to the left. And that is what we will do. And we're not going to connect the points because that's not the final graph. The final graph includes -8. So now I need to move all these points down -8. And there's a reflection here. So I can just, I don't really have to count, I can just reflect it over the or over, not the y-axis, but kind of that y-axis direction. Okay, since that's the final graph, I'm going to go through and I'm graphing, and I'm going to estimate best as I can, and then I'm going to make sure I have my arrows on the graph. So that is your function for number 4. So we're leveling up, right? Each time we're doing a different concept and then combining them. So now let's go to the next one. So now we need to do a vertical stretch. A vertical stretch, and this is the one that's a little bit more challenging. So I'm going to write out the parent function for this one, and then I'm going to write out the new graph that I would like you to show me a vertical stretch on. So I'm going to put my parent points over here. Hope you're getting fast with that. Now here's the thing. This graph, I'm telling you ahead of time, is going to be skinnier, but we have to be very precise where those points are. So in this example, when you have a number out in the front, which represents the A value in the formula I showed you at the beginning of the video, the A value, it is best if you make a table from the parent function. So the black is the parent function. And I'm not going to go through all the computation because hopefully at this point you are starting to really memorize, or you understand exactly where those numbers are coming from. And remember, f of x is y, so I'm just going to leave it like that. The black is the original function. Now what's happening is we're supposed to take the original function, which is x squared, and now multiply it by this blue 3. And that's exactly what I'm going to do. I'm going to take all of the values that are y, so the y values, and multiply them by 3, because this part of the equation is actually the y part, which is the original graph. So what's that going to look like? Well, I know you can do this in your head, but I do want to show you where they're coming from. Later on, it may not be as obvious, but I don't want numbers to just magically appear. I want you to really understand where the calculations and how they connect to the graph, how they really work. Okay, I have my parent graph, which is in black, and now I'm going to start graphing the new vertical stretch, and I'll write that word up at the top so you understand what the transformation is. So I'm going to just start at 0, 0 so I get a little orientation. So that point is exactly in the same place. So now I have -1, 3. So that's the point that I'm going to graph next. So 1, 2, 3. So you can see right here, the original point was at -1, 1, but I multiplied the y value by 3. So it jumped up here 3 units. So it's growing 3 times faster than the original function. Now I can't just go 1, 2, 3 here, because that would give me a straight line, and I need that nice curve. I'm now going to use reflection across the y-axis in order to get the next point. So I have these 2 points here, and then I'm going to graph finally -2, -2, 12. And if you look at my graph, it goes up to 10. So I'm just going to eyeball it up here and just go off the paper a little bit. You may be using regular graph paper and you're not confined by this axis or notebook paper, so just understand, I mean, you can always extend that graph out. And now you can see the graph, the new one, is really skinny. You can see it. So this is a super skinny graph. And so what did we do? We just did a vertical shift. And what is that vertical shift controlled by is the following. It's controlled by the function in general right here. So that is the vertical shift. So this function is growing 3 times faster towards infinity. So I'm going to do one more example for you. And if you don't want to write this one out, I'm completely okay with that. In fact, I'm not going to number it. I just want you to watch it so you understand where the values are coming from. Sometimes it's just good to see a process so you don't get too bogged down. So this is just another example, so you don't need to write this. And this time I'm going to use, let's use 2 as my A value, which is the vertical stretch. So here's my parent function. And I better label things so you know exactly where they're coming from. Every day I want you guys to learn something new, or at least review it in a way that you really feel like you have it mastered. So the 2 tells us to multiply all the y values by 2, or double them. And so that's what I'm going to do. So here is that vertical stretch where we're growing twice as big, and then I'm throwing in those x or sorry, y values, right? The y values. So 4, 1, 0, 1, and 4. Okay, really try to think about where the values are coming from. And what are we doing? A vertical stretch. So I'm going to put my parent graph on here so I can make a comparison from the parent graph to the new graph. And this time I'm going to write the points out. It's a little bit more organized. If you don't wish to do that, that's fine. But since you're watching the video right now, I want to be a little bit more precise. So I'm going to start with the easy one, which is 0, 0. And then I'll move my way to the next point and use reflection like I was doing. So right here, remember this point was at, so let me put it in a color so you know what I'm talking about. So that point was the point -1, 1. And I have a transformation happening where I multiply the y's by 2. So what happens to the y value? The x stays the same. That's how we get the position of that point. But we take the y value and multiply it by 2. So that is our new point. So I'll highlight that so you can really see where that's coming from. You can see it's twice as high. So now I'm just going to clean up some stuff so I don't want it to look crazy for you. And then I'm going to make sure I count this one so I don't, make a mistake and put it in the wrong place. So 1, 2, it's negative. 1, 2, 3, 4, 5, 6, 7, 8. And then I'll use my reflection. And I'm going to double check there's one at -1, there's one at -2, and likewise on the other side. So the graph is skinnier again, and that's what I want you to see. And we have one final graph. So now we're going to put all of these things together, and believe it or not, this is not the end of the different types that you do, but it's enough for today. So we'll pick up on the other types later. So this one is number 6, and you do need to write this one out. So write this out. So here's our parent graph, and I'm going to put everything together now. This is just our general formula. And we're going to put everything together, and we're going to graph what you have done in previous examples. And I'm going to change some of the signs, so if you think, oh, where did that come from? I'm just letting you know I'm using the same numbers, but I want to change the signs up just a little bit. And don't forget the square, because the square tells us that we're going to have some kind of graph that's a U. So some kind of graph that's a U. So it looks like I have a vertical stretch this time, which tells me right off the bat, I need to make the parent function. The minute you see that, you need to make the parent function table. And so what this says is you need to now take all of the y values and multiply them by 3. So that's what we're going to do. So multiply all the y values by 3. And of course, you've done that before. So we're feeling good. Just wanted to make my sign was right, and I was getting ahead of myself. So we gotta go back and fix that. So here's the 1, and then 1 and 4. And I think it's really good that you see the repetition here over and over again so you know what's going on. So there is my vertical stretch. So you do the vertical stretch first. Always do it first. So what we graphed in pink was 3x squared, and that's where we're going to start the graph. So I'm going to put my parent graph on there so I can make a comparison of where I started and where I made the transformation. So that's what we're going to do. Not connected because that's not what we're ending up with. And then we're going to graph the vertical stretch. 1, 2, 3, and then reflection. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Remember, I'm going off the graph just a little bit. And I'll label that point so you aren't confused as to what it is. And then I'm going to use reflection, and that one is 2, 12. And you really can see the reflection right here where the x values are different, but the y values are the same. Okay, that's not our graph. Now we're gonna have to shift this graph. We're gonna have to shift it. So I no longer need my table, but you keep it on your paper. So the shift is quite a bit easier. I'm gonna use blue for the shift. And I'm leaving this black because that's the original. That's part of the original. That's how you know you get the U. And then I'll rewrite my function. So what are we doing? We're doing the horizontal and vertical shifts. So I'm going to rewrite my function out so I know which direction I'm supposed to move. And I'm only writing this portion of the graph because I'm not going to worry about this -8 right now. I'm just going to move this function like we've done in the previous examples. So we're going left 2. So I'm going to take these pink points and go left 2. Oops. So it's a good idea to be using colored pencil or highlighters or something, but if you're not, make sure that you're keeping track of everything. And here's a tip. Sometimes what I will do is I'll start with the parent function as a circle, then I'll move the next transformation as a star maybe, and then I'll change the symbol to maybe an @ sign or a heart so I know which graph is which if I don't have any colored pencils. Because this would be really tough for you guys to learn if I wasn't doing it in color right now. All right, we're finally to the real deal. The whole entire graph that you've been asked to graph since the very beginning. I'm going to rewrite the function so it looks pretty again. This is my original one. And of course, all this is on your paper. And let's see, I'm gonna get rid of these just because of the teaching, right? I want to teach you this stuff so it's a little bit more clear. There's not a whole bunch of crazy looking stuff on the paper. All right, the last thing we need to do is move everything down 8. So we're going down, this is your vertical shift. So up and down. So you're going to move all the points down by 8. And I'm actually looking, and there's a rate of change right here that is a difference of 3 on the y. So that's kind of what I did. So if you're wondering where I got this point so fast, I'm copying that down because again, it's a rigid transformation right now because the shape isn't changing, so I can do that. So it kind of helps a little bit. Okay, these I'm going to actually move down 8 because I'm off the grid. And I'll use transformation of that reflection. And then I finally have my graph. Ta-da! And that is what you should be learning today. So this video was on transformation of graphs, of quadratics specifically. And I hope that you are really understanding. Make sure you ask me questions tomorrow if you need anything.